we are about to begin our special lecture this afternoon. I'm very honored to introduce Professor Bertrand from France. He has been a friend, and we worked together on some topic on the theme of autism before. But he has been a long-term friend and serving as an advisory board member for our former NRPB national projects, and currently is the NRPB advisory board members. And Professor Jordan has a long history of research and achievement. And he worked for the Marseilles Genome Pool, and also currently now on the advisory board of the CORE Bio PACA facility. So today he will talk about the topic is autism, the elusive gene. So let's welcome Professor.
Well, thank you very much, Daniel, for the nice introduction. Yes, I think we already, or at least with some of the audience, we already discussed this topic maybe 3 years ago, but it has grown and changed quite a lot, so I thought it was worthwhile to go back. I'm not a specialist in psychiatry, definitely not. The reason I got interested in autism is that first there was a story in which I became involved, which you will hear about. And also I think it's a good example of the complexities of diseases that have a strong genetic component, but yet where we have a lot of trouble finding the genes involved, because there are many genes and the effect of each of them is quite small. And it's also a good example of the way in which the biotech industry and basic science and the public interact, not always in the best possible way. I'm also quite involved now. I mean, I'm basically a molecular biologist and a genomic person, but I've also been involved quite a lot as an advisor to biotech companies. So this is a world which I know, I'm beginning to know very well. So, and actually this is the title of my talk is the title of a book that will come out in France in January. This will be my 11th book about science, genetics, and so on for the general public. I hope it will eventually be translated into several languages, including Chinese. And actually, by the way, I'm very proud to have had one of my books translated into Chinese. This is it. It's called the Love Song of the Sea Cucumber, and it's been published in mainland China, but I hope it will eventually be published in Taiwan as well. And it's really a book about evolution, or around the topics of evolution. Okay, so autism, the elusive gene, actually is better than the untraceable gene. Well, that's how the story started for me, with an article in France, in Le Monde, which is I would say, our most respected newspaper, a bit like the Times in England. So that was an article 5 or 6 years ago, announcing that a French company was going to launch a diagnostic test for autism. That's my translation, of course. And so it announced that this company was going to launch a genetic test for autism. These are the actual words of the company on the company's website. And the journal, the newspaper also said this would be a home test, which sounded quite strange. I mean, a home test like a pregnancy test. And actually this is what you could find at that time on the website of the company, and indeed they did announce the world's first genetic test for autism, allowing the identification of individuals at a very early age, and to be launched very soon. This was summer 2005. It was supposed to be launched early next year in the US. Okay. So at first sight, this looked quite surprising and a little disturbing. Quite surprising because from what I knew at the time, autism was very complex, and no major gene had been found, and it seemed very unlikely that one could produce workable, reasonable genetic tests. And also disturbing because, of course, in such diseases one has to be very careful about what is announced. People, the general public tends to believe that genes determine everything, and you can reinforce that belief by such announcement. And also home tests, sorry, I have to go back. No, I'm going forward. No. And I mean, home tests seemed like something very unlikely. Well, let me clear that up immediately. This business of home tests was a mistake on the part of the journalist. Presumably he had been talking with company officials and they had said something about home brew. Home brew means a test that is done in a company's own lab, not sold outside as a kit. So this is called, colloquial term is home brew. The official term is LDT for laboratory developed tests. And so apparently the journalist had mistaken home brew for actually a home test, something which you do at home in your kitchen. So this is actually wrong. But this made the news even more strange. Okay, so this is what was announced on the website of the company. So let's go briefly over autism, because maybe not everybody is familiar with it. Just some basic facts. So the picture I showed, and which is shown here again, is actually from the Wikipedia piece on autism, and it shows a presumably autistic child who has one of these manias. In his case, it's putting all his toys in a very strict arrangement before he can go to sleep, and presumably if one of the toys is out of line, there's no way he can go to sleep. This is one of the symptoms, but there are many others, and basically these people have trouble having social relationship, acquiring language, and so there are of course difficulties being inserted into society, and they very often are not able to lead an independent life. And the prevalence is quite high, at least using a fairly wide definition. There's a lot of discussion. The prevalence has grown a lot in recent years. There's some discussion about whether this is really increasing prevalence or just increasing attention and wider diagnostic criteria. But anyway, it's in the range of 1 and 150, which is pretty high. Okay. Now, particularly in France, this is a very sensitive topic because, as you may know, in France, we still have a very strong influence of psychoanalysis as a, well, it's supposed to be a science. I don't think it's a science, but that's a matter of debate. And anyway, autism is, by many people, including many MDs, still considered as an infantile psychosis, and according to, well, to a certain extent, to the inventor of the term, Leo Kanner, who published the first paper in 1943, but also to Bruno Bertrand, who is well known here, Françoise Dolto, who is, well, better known in France, I guess, than over here. Autism is supposed to be the result of difficulties in the relationship between the mother and the child. The mother somehow doesn't recognize the child as a person or as a child, and the child retreats into isolation, into this, what Bertrand called the empty fortress. So the prevalent view of autism, at least in France, is still that it's a disorder of the mother-child relationship. Maybe it's no longer the prevalent view among psychiatrists, but it's still very widespread in the general public and in nurses and people like that. And it has, of course, pretty serious consequences for the children involved and also for their parents who are charged with a responsibility which is not really theirs. By the way, we have lots of time, so if at any time you feel a question, please ask the question right away, because by the end of the talk you might have forgotten it. So by now we do know that there is a very strong component in autism. This has been shown most convincingly. Sorry, I still have. Still clumsy with this. This has been shown most convincingly by looking at the concordance in real twins and false twins, in monozygotic twins and dizygotic twins. So concordance means you look at a twin pair. One of the twins has been diagnosed as autistic, and what you look for is whether or not the other twin has also been diagnosed as autistic. And what is found is that between monozygotic twins, the concordance is very high, and between dizygotic twins, the concordance is significant, but is not larger than for any siblings in the same family. So this is a very strong indication for the strong influence of genetics, because whether the kids are monozygotic or dizygotic twins, they are born together from the same mother, they are raised in the same environment. So presumably the environment is as similar for dizygotic or two dizygotic twins as it is for two monozygotic twins. And so if the concordance is much higher for monozygotic twins, it must mean that the genes are involved, because of course monozygotic twins have almost exactly the same gene alleles, not quite, but almost, while dizygotic twins only have on average 50% of shared alleles. So if there is such a strong genetic influence, then of course one expects that one should be able to find genes for which some alleles protect and some alleles predispose to the syndrome. This is just some of the original data. One of the first papers, it's just part of a figure of a paper published in 1985. So you have here several sets of siblings. The monozygotic twins are shown by this linkage between the two symbols. And so this is a monozygotic twin pair, this is a dizygotic twin pair. And of course the affected individuals are shown in black and the unaffected ones in white. And as you can see, almost all dizygotic twin pairs are concordant, which means if one of them is affected, the other one as well, while most dizygotic twins are non-concordant. Sorry. This is only part of the data. There is more data in that paper. Actually, there have been one or two papers very recently which lower a little this concordance, but still the concordance is much higher for monozygotic twins than for dizygotic twins. And this is an indication that there is a genetic component, either genetic vulnerability or really genetic quote-unquote determination. So monozygotic twins around 85%, dizygotic twins around 10%, siblings also around 10%, and of course general population 1%. apart from genetics, there is also some physiology. It's now possible to do functional brain imaging to find out which regions of the brain are activated during certain tasks, like showing a child animals and asking him to name them, or tasks like that. And it seems now really established that you have significant differences between the areas that are activated for a certain task in normal individuals and individuals that have been diagnosed as autistic. And well, generally speaking, this is very complicated data, and I'm also not a neurobiologist, but generally speaking, this seems to be related to problems of connectivity between synapses, between the neurons. And it's visible very early. So again, this confirms that autism is definitely not a psychological reaction to some kind of trauma. It's really a physiological problem, a neurophysiological problem with some gene alleles giving a strong probability. Okay, in terms of therapy, as I'm sure you know, there's no really highly effective therapy for autism. There are many phony therapies around. This is one which again has quite a strong following in France and has had a lot of negative exposure. Recently, something called packing, which involves wrapping the autistic child in cloth, in sheets that have been kept in the refrigerator, and then letting the temperature go back to normal while he is being talked to by therapists. This is supposed to be, by its proponents, it is said to be effective in cases of automutilation, which is one of the complications of autism. It has no scientific basis whatsoever. You have things like this saying that vaccination is the cause of autism. You can see this picture where the hand in your creating those poor children is this is highly spectacular. You have also quack doctors like this that claim to cure autism by various things, like this Dr. Chun Wong. You have more serious therapies, behavioral therapies, two major methods, one called TEACH, one called ADA, which through fairly intensive behavior therapy can indeed succeed in making those children more capable of interacting and of following some kind of school curriculum and have better integration. But there is no miracle. It's definitely not extremely effective, but it can help. And those actually the only method that have undergone reasonable scientific evaluation and that have shown some effectiveness. Okay, so much for the general presentation of autism. Well, the only thing on which everybody agrees is that whatever therapy one is using, it should be done very early, as early as possible. Yet, presently, the diagnosis for autism is really reached by the age of 3 or 4, which is very late, which is the time by which brain plasticity has more or less disappeared. So indeed, if a good genetic test was available, it would probably be useful because it would allow to start therapy very early and to get better results. So there is a real, besides scientific reasons, there is a real reason for trying to find genes involved in autism or in vulnerability to autism. So what has been done? So now I'll just like to paint the picture as it was by the time this announcement was made, which is 2005. I'll come back later to what has happened since in terms of scientific work and discoveries. So as you may remember, psychiatric genetics has been very much in fashion already in the 1990s, and generally it's been a miserable failure. After the first successes of medical genetics, finding the genes for muscular dystrophy and cystic fibrosis and Huntington's disease, then there was a lot of excitement and a lot of work trying to find the genes involved in, sorry, I have trouble finding the names, for example, schizophrenia, in manic depressive syndrome, and all those psychiatric diseases for which there is indeed a genetic component, and autism was among the lot. And I would say, as with the other psychiatric diseases, these efforts failed in that they found many loci, different loci in different studies, sometimes conflicting results when the same set of patients was analyzed by two different labs, and generally fairly low statistical significance. Even at that time, it was clear that only log scores above 3 were likely to be somewhat significant. You have to remember that by that time, these are all genetic mapping exercises, looking at the number of cases, controls, and trying to find alleles that are, well, markers that are associated with the disease. And at that time, this game was played with a pretty small set of markers, something like 200 markers to cover the genome, which was enough to find the gene for Huntington's, or the gene for the gene variant for Huntington's, or the one for cystic fibrosis, but definitely not enough for something complex like autism. That was the 1990s. Well, by the 2000s, we were able to use so-called microsatellite markers. If you remember those, we had a pretty good genetic map with a few thousand markers all over the genome. So genetic mapping got a bit better, but the results were still quite tentative, contradictory, and the situation was still very unclear. So indeed, this is a review published in 2006, so it more or less summarizes the state of research by 2005. That is by the time this announcement was made by this French company. So it did seem very strange that a company should be able to announce a genetic test for autism, given those results. Okay, so this actually summarizes what I was saying. So now let's look at the announcement of the company. So this is in 2005. This is also from the website at the same date. So basically what they say is that their test looks at 4 genes. So it is an attempt to take into account the fact that the genetic component of the syndrome is complex. And well, basically what they say here is that in the most extreme case, where one child has all the risk versions, the risk alleles, then his or her relative risk will be around 50, which means this child would have a risk which is 15 times the standard risk in the population. So this sounds fairly impressive. But actually, if you look at the figure, it was announced also, for example, on the sites of autism charities, like Cure Autism Now, which I think has changed name now, but anyway, autism gene isolation. using samples from that charity. So this is the actual paper. The announcement was based, or was simultaneous, if you want, with a scientific paper published by the company's scientists. These are all people working in that company, IntegraGen. And actually this paper was published in quite a good journal. This is a journal with an impact factor of 10, so it's quite respectable. But as you can see, both the title and here the conclusion of the paper are quite careful. Haplotypes in the gene PRKCB1 are associated with autism, and the conclusion, our data provide evidence that the PRKCB1 gene may be involved in the etiology of autism. So this is a careful scientific conclusion, supported by the data in the paper, but it's of course quite far from being an autism gene that's going to be able to predict. So to do this, they studied a reasonable set of families. They have a special mapping method developed in that company. They found 7 chromosome regions that appear to be associated with autism, and the most significant of them contains this gene, which looks like a good candidate because it's expressed in the brain and it's involved in synaptic transmission. Well, unfortunately, they didn't see an alteration of this gene in patients, which is usually what really clinches the results in such studies. So, as I said, their conclusion is careful. But as we saw, the announcement from the company is much less careful. And indeed, if the relative risk is 15, well, what? Sorry. So, sorry. What they say. My slide arrangement is not very good, but anyway, what the company says, what was in the previous slide, is that if all 4 genes have the quote-unquote bad allele, then the relative risk is 15-fold. And actually the test, the use they propose for this test is first in families where there is already one autistic child, to test the siblings to find out if one of them is at high risk. But they say also that they hope that eventually the test will be improved and can be used to screen any child who looks slightly abnormal. And again, they announced that the test will be marketed in 2006, which means 6 months, basically, from the date of the announcement. And indeed, if what they say is correct, well, positive test in such a case would mean a 15-fold relative risk of 15-fold higher risk of autism. If we take the standard risk as 1 in 150, as we saw before, that means a positive child, according to the test, would have a risk of 15 times 1 over 150, which means a risk of 1 in 10. Which means that actually 9 out of 10 so-called positive children would actually be false positive. So this doesn't look like a very good test, because of course you want a genetic test to give you few false positives and also few false negatives. And in this case, if you label 9 out of 10 children, if you label them falsely as possibly autistic, as high risk of autism, there is a risk that this will have an influence on the behavior of the family towards these children and actually increase the risk that they will have some kind of psychological problem, just because they are regarded as potentially autistic. I'm sure you remember those experiments where children chosen randomly in the class were indicated the teacher as especially bright or as especially dull, and indeed the ones which were indicated as especially bright got better results, because actually the behavior of the teacher towards those children was different, even though there was no objective basis for that. So it doesn't actually look like a good test. And in fact, there was a lot of reaction to this announcement. I myself published a paper about it, and there were strong worded comments by a number of autism charities. But maybe one of the most strongly worded criticism was published in a magazine which actually is published by Handicap International, which is a well-known charity. They have managed to more or less outlaw landmines, for example. And so the title, well, this article, the title of this article was "Who Profits by the Crime?" And you see here a dollar bill with pills. So the idea is this is, well, and the article itself, if you can read French, it's really very strongly worded, and it says that this company is completely responsible, that they are just looking for money, that they don't worry about what's going to happen to the false positives, and so on and so forth. And actually, the company had a libel suit against this journal, which is shown here. So December 2006, and basically it asked for €100,000 damages, which is quite a lot of money, especially for a small publication. It can be enough to make it problematic to survive. I was actually asked as a witness to the trial. Unfortunately, I couldn't be a witness because I was in Taiwan. But not as a result of my absence. The company won. The company won the libel suit. They didn't get €100,000. They got what we call one symbolic euro. But they did win in principle, and they did get publication of the judgment in 2 or 3 magazines. So even though they didn't get a big pot of money, they actually won something. So even if the paper was indeed a little inflammatory, it could have been worded more carefully. It looks like really a paper that someone wrote and then just published without sleeping over it and having another look. But still, it's really a problem if when a newspaper criticizes a company, this company can actually win a libel suit against the newspaper. It reminds us of what happened with tobacco. The tobacco companies really managed for 1 or 2 decades to prevent the link between smoking and lung cancer from being acknowledged. And of course, during this time, they made a lot of money, and during this time, a lot of people got lung cancer. And so this is an example of the kind of advertising that was common in the 50s, involving doctors and reassuring people that smoking was okay since the doctors smoke, but there was a lot more action, like bribing officials, publishing false scientific studies, persecuting scientists who published studies showing link. I mean, it was really very dirty business. I'm not saying that Integragen is as bad as Philip Morris or whatever, but there is some connection. Okay, so actually the test did not come out in 2006, and did not come out in 2007, did not come out in 2008. And in the meantime, there was more research on the genetic correlations of autism with better and better technology. Because now we can do whole genome association studies where you look at 10,000, 100,000, even now 1 million markers all across the genome, and look whether there is any association between certain alleles of some of these markers with the condition. Looking at a few thousand patients, a few thousand controls, and one of the earliest and largest studies was published in 2007. So it involved 7,000 people, 138 authors, looking at 10,000 markers all over the genome for all these 7,000 people. And this is the kind of results they obtained. So what it shows is a scan across the whole genome, the various chromosomes from 1 to 22X. And here, well, you can't quite see the scale, but it's the probability that the result is not false positive. Because of course in these studies you are looking at many patients, many markers, and there is always any association you see could be due to chance. So you have to apply very strict statistical criteria to be reasonably sure that what you see is a real association and not just a random fluctuation. So this is the statistical probability that the result is solid, and this is the line above which the result is considered pretty sure. Of course, never 100%, but with a really good chance of being statistically significant. So you can see there are lots of signals on lots of chromosomes, but really only one that is above the limit. So indeed, this genetic influence on autism must involve many genes, and to find them it will require different experiments or even more people, more SNPs, and more work. This is already a very big piece of work costing billions of dollars. Also, during these periods, we realized that single nucleotide polymorphism, so-called SNPs, are not the only type of variation in the human genome, that there are also differences involving small, or in some cases fairly large, deletions or duplications, pieces of DNA that are missing in some people, that are in several copies in other people, so-called CNV, copy number variations. And indeed, some of these CNVs appear to be linked to autism. They are a minority, but there is, in some cases, fairly significant linkage. So it's not only point variations, but also some deletions and duplications that seem to be involved in autism. And then also, it was found that in some cases, particularly in some family studies, you have de novo events, alterations or variations that are not present in the father or in the mother's DNA, but are present in the child's DNA. And so that must be a result of a new mutation, a new point mutation, or a new copy number variation that happened with the child. In some cases, families where you have two affected children, you find the same de novo change in both children. And so in that case, it's pretty strong evidence that this has something to do with the syndrome. So we have made progress, but the picture has become more and more complicated, not only point mutations, but also deletions, duplications, and not only inherited changes, but also de novo changes. So we still have this relative paradox. We have a syndrome that is largely determined by genetics, but we have a lot of trouble finding the genes, even with the most powerful technology. And of course, this means that developing a really useful genetic test is going to be very difficult. Now, this problem here, this elusive gene problem, is not limited to autism, and it's actually quite general. And it's the so-called missing heritability problem. We are indeed now in a situation where we have a number of diseases or conditions where there is clearly a very strong genetic component, where using new technology, one has been able to find a number of genes that have some influence on the disease, but we don't account for all of the heritability. For example, if you take height at adult age is a very strongly inherited component. The heritability is something like 0.8, 80%. Of course, heritability of 1 means it's entirely determined by genes, and like Huntington's chorea, for example, and heritability of 0 means it's entirely determined by the environment, like flu infection. So for height, the heritability is 80%, very strong, and one has by now found, I think, more than 50 genes that are involved in heritability. But these genes, all these genes taken together, they only account for less than 20% of the heritability. So we are missing a lot of it, and well, there are technical reasons for that. I'm not going to go into detail. It's one of the big problems in human genetics right now, finding where is the missing heritability, and it has to do with the frequency of variations in the genome and the limitations of the methods we are using, and also probably some things we don't understand yet. But this is again, this is quite this is a general problem. Also with purely organic diseases like Crohn's disease or even diabetes. So it's not limited to more psychiatric diseases. Of course, then you have the problem of, especially with something like autism, it's probably very heterogeneous. What we call autism is probably a number of different conditions that we lump together. And so, of course, when we take patients suffering from any type of autism, it makes it even more difficult to find the genes involved. And then we have this involvement of de novo mutations, which makes things more difficult. I think, for example, for Crohn's disease, this is beginning to be worked out. I mean, this type of approach was sort of plateauing at 20 or 30% of the heritability, and now newer studies that look at rare variations are picking up. Okay, so this is the landscape. So what has Integrogen been doing in the meantime? Actually, even though I was somewhat hostile to what the company was doing, I have had frequent interactions with them. I visited them a couple of times, and they have continued working on autism, and in fact, in 2005 it was one of their topics. By now, it is their major topic. So, this is actually an interesting question: why would a company devote most of its activity to such a difficult question where it's unlikely that they can make a good test. And we'll come back to that. But they have published a respectable number of papers and poster sessions or presentations and so on. There's a very abundant literature about the genetic aspects of autism, so they are a small part of that, but they are contributing. And fairly recently, they had a paper which describes what you can do with 4 genes to determine the autism risk. So I think this is the paper. So this is their most recent paper, published in 2010 in a new journal, but it's supposed to be a peer-reviewed journal. And essentially, what they do, like in this article, is to describe in detail the test that they announced in 2005. In 2005, they announced a test based on 4 genes. Only one of these genes was published, and 3 others are just referred to in their advertising, but they didn't say what the genes were, what the results were. So actually, in this paper, they do describe the 4 genes in detail, and more importantly, they show really the results of the test, and that's what we're going to look at. So this is we'll spend a little time on this graph. So what they did is take a number, I don't remember the number, but a fairly high number of children who had already been diagnosed as autistic, and an equivalent number of controls. I think it was like something like 200 children in each category. And then they performed the test on all of these children, autistic and controls. And here they plot the results according to their genetic score. What they call their genetic score is the result of their tests, and 8 is the highest score giving the highest risk, and of course 2 is the low score giving the lowest risk. And so what you see here, the black bars are the autistic, the children that have been diagnosed as autistic. Of course, the test was performed without knowing which child was normal, which child was autistic. And the gray bars are the norms. And it's expressed as the percentage. So for example, here, this means that for a genetic score of 5, you find 31% of the autistic cases and 38% of the normal, of the control individuals. So what you can see is that as the score increases, you have proportionally more and more autistic children. So for 8, you have almost only autistic children. For 2 or 3, you have mostly normal children. But it's obvious that the separation is not very good, not good at all, because what you would hope for is that above a certain score, almost all children would be autistic, and that's not at all the case. So if you take this data and you compute specificity, sensitivity and specificity, which is a standard way of assessing the quality of the test. Let me just have a little look at that. So this is, I'm sorry, this is in French, but I'm sure you can. So this is, here the test is negative, here the test is positive. These are affected individuals, these are control individuals. So ideally, all the affected will test positive, none will test negative, and also ideally all the controls will test negative, and none of these will test positive. Of course, in reality, things are never perfect. You have a small fraction of patients who test negative, so these are the false positives, and you have a small fraction of controls who test positive. These are the false positives. So sensitivity, what we call sensitivity, is the fraction of affected who test positive. Ideally, it should be 100%. For example, for a commonly used HIV test, it's 99.4%. And specificity is a fraction of controls who test negative. Again, ideally, it should be 100%. For an HIV test, for example, it's 97.6. When you are doing a screening test, like HIV test, you'd like to miss as few positives as possible. So you want a test with very high sensitivity. If the specificity is not very good, that means you will have some people who will test positive when they are in fact negative. Of course, when somebody tests positive with the screening test, then you do a second test, which is more expensive, more slow, and which will eliminate the false positives. So people will just be anxious for a week or two, and then they will get a good result. But at least you're not going to miss people who are actually infected. So it's always a balance. If you want very high sensitivity, you may have to compromise on specificity and vice versa. So in this case, really, and this things looks very bad, because if you take as positives only the children with a score above 6, so these, just these, you're going to have only a small fraction of the affected children, something like 17%. And then your specificity will be relatively good. You won't have too many false positives. But if you want to increase the sensitivity, if you take all scores above 6 as positive, then your sensitivity is better. But now your specificity has gone down a lot, and you're going to classify many controls as positive. So whatever way you do, the test is not really good. However, in fact, this test, or a closely similar version, has been marketed. It's been marketed late last year by a company called, the name escapes me, I'm sorry. In US, Transgenomic, which, if you're familiar with the field, it's a company that's known mainly for making the so-called wave system for S&P scoring, a system that's largely out of date by now, and the company is probably trying to reinvent itself as a genetic diagnosis company. But anyway, so they marketed this test, which they called the A-risk, familial autism panel. It was actually based on 8 genes, so the 4 preceding plus 4 new genes. They had a so-called white paper, which is actually a paper that has not been published in a journal, that's written as if it was a real paper, which showed slightly better performance. So this was indeed announced and marketed according to the site of IntegraGen, but I was surprised to see recently that it has now disappeared. The addresses I previously had just now lead to a general description by IntegraGen, and so apparently they tried to market this test and probably either did not get any orders or were criticized. I don't know the inside story, but the end result is that the test is not on the market. Okay, so this is, I think I'm coming to the end. So what about the future? As this test, well, a good genetic test for autism risk would certainly be useful again, because if it allowed you to detect autistic children at an early age, it would help to have better treatment and to improve the quality of life for these children and their families. However, at this time, as we've seen, the current tests are very limited. They don't really discriminate children at risk and normal children with any efficiency, and there is a serious risk of misuse of these tests. But maybe in the future, since autism is probably a mixture of different syndromes with different etiologies and maybe different genes involved, so maybe in time identification of genes that have an influence will allow the understanding of the number of pathways, and maybe allow to subdivide autism into several different syndromes, which may have different therapies, in particular in terms of drug therapies. So this may help not only detection but also therapy in the future, but we're not there yet. And so, question one might ask is, given this fairly hopeless current situation, why would a company put all its efforts into this type of work? Well, this is a case where actually the market is waiting for our products, and the market is quite significant. There's something like 30,000 new cases of autism per year just in the US, about as many in Europe. It's just 1% of live births. And if such a test is used, it will probably be used not only on those who turn out to be autistic, but on a number of likely cases. And a fairly complex test like this is usually sold around $1,000. So it adds up to quite a significant market. And in fact, both the parents and many doctors are really waiting for a test. They would like to have a test. They hope, they expect, and they are wrong in this expectation, but it's quite ingrained, that the test will really, because it's a genetic test, it's going to be black and white and tell me this child will be autistic or this child is normal. This will never be the case, but this is a widely spread misconception. And of course in the US, doctors are always afraid that eventually they will be accused of not having done a test that could have had possible results, so in a doubt they will order the test. This is already happening for breast cancer prognosis, for example, so it's certainly a factor. So, conclusion, even though we've made really a lot of progress in analyzing genomes, and we can now sequence genomes, and we can do a lot of things, and we have solid scientific data, because those associations that are found, they are valid and reproducible. They just don't explain enough. So we still have a lot of problems going from the genes to the phenotype. I really like this drawing where the MDs are looking at the gene sequence. It doesn't really help them to understand why this patient is feeling so bad. And I think I have another take-home lesson. So this is another drawing which I think is really very, very good. And so I think this shows the contradiction that may exist that exists in some cases between business interest and a responsible approach to diagnostics, and which means that we really need effective regulation, which is not easy. And I think that's the end of it. Yes, thank you.
Bertrand, thank you for your wonderful talk. That has a great ELSI implication and reflections for our audience. Especially we know that in this hospital we have team working on the autism gene too, and we also have some child psychiatrists geneticists visiting today. So we are now open for question and answer. And any comments? Questions?
the landscape of regulation in terms of these new genetic tests in France. Apparently, the interpretation of these genetic tests is very complicated. And surely I think parents need some gatekeepers to avoid confusions that you have warned against. So is there any regulation before a test gets on the market and can be provided by physicians as opposed to some of the home tests that initially was presented that are directly marketed to consumers?
Well, in France, the regulation is very restrictive. DNA testing can only be done if ordered by a physician or by a judge. And for example, if I send my DNA to complete genomics for sequencing, I can incur a heavy fine and I think even 1 year in prison. I mean, which is somewhat ridiculous because it's impossible to enforce. But anyway, that's how it is. Now, in terms of approval for use by MDs, I mean that's a bit similar to FDA. It's CE IVD approval, which is well, mostly dependent on the test being done in a reasonable environment, not on proven clinical utility. However, of course, we have like Taiwan, a national health system, and so the national health system is not going to pay for the test unless it has to be proven to have some utility. So I think, no, there is also demand, to a certain extent, demand from the parents and to a certain extent from the autism charities for genetic tests, but the situation is not as freewheeling as in the US. There was a question.
Yes, Kevin G. Kevin first. So, I have two questions. The first is that you mentioned that the concordance rate between the monozygote twins is pretty high. I'm wondering that if there is any kind of adoption studies into this, such that we can always rule out the social or the nurturing effect, because many monozygotic twins were raised together. So maybe that's one part that we should verify first. Okay, then after you answer the first question, I'll ask the second question.
Okay, so the first question is whether there are any adoption studies like twins a year apart would be ideal. As far as I know, no. I mean, these studies, it's not easy to find twins that have been reared apart. It's not easy to be sure that they have really been reared apart with no contact. And I know in the past, many of the studies on twins reared apart have been quite heavily criticized. However, I mean, the dizygotic twins, they are also raised together as the monozygotic twins. So unless the parents behave more similarly to the two members of the monozygotic twins than they do to the two members of the dizygotic twins, I mean, the difference in concordance more or less eliminates the role of the environment.
Yeah, I understand, but it still could not be ruled out that this multi-genetic scheme or something like that, the profile still need the nurture effect, the environmental effect to make them work, to make people autistic. It is possible.
Yeah, I mean, it's, and in fact, so the recent work I alluded to reduces quite significantly the concordance for monozygotic twins to, I think, 60%, and increases the concordance rate for dizygotic twins to something like 15%. So the difference is still there, but it's not as high as it used to be. And it's a paper that was published just a few months ago, I think in the Lancet. I'm not sure. I remember. But and what the authors suggest is that there may be actually a shared environment during pregnancy, something happening during pregnancy, which increases the risk of autism, and that would then affect both dizygotic and monozygotic twins.
Okay, many thanks. And my second question is that, because according to your argument, it seems to me that it is inevitable for people to misunderstand what those genetic tests means. Because you said that there is a huge market waiting for these new genetic tests. I'm wondering that you want to regulate these genetic tests, but there might be two ways to approach to regulate. And the first one is that maybe you just say, okay, if you do not show your scientific validity, the government would ban the marketing of these genetic tests. That would be the first one. And the second one is that maybe some people are more market-oriented. They will say that we will allow you to sell those genetic tests, but we want to warn the people that this is not useful. Please pay attention to this. And then if there's nobody wanting to buy those genetic tests, then no company would do this. So which one would be the major focus? Educate people or to regulate these genetic tests? Which one?
Yeah, I mean, I think the only hope is education. But you can see that now when you buy cigarettes, you have smoking kills written large on the packet, and still people continue smoking. So and outlawing a test in the internet era doesn't make sense. I mean, paternity tests are also outlawed in France unless ordered by a judge. But of course, anybody can do it by sending a sample to England or whatever. And it's almost impossible to regulate that. So I think we have to try and make understand what this kind of test really means and what it cannot say, and hope eventually people understand that. Yes?
I have a question, I'm not sure how to frame it. When you presented the initial media release of the 4G test, you said that it's marketed in terms of it would allow for early diagnosis and hopeful treatment. And you use that language subsequently when you commented about other tests. But for a disease like autism, unless you fall back on your French heritage and say it's a psychoanalytic explanation, what are these interventions that are going to fix it? You see what I mean?
Yeah. I mean, the behavioral treatments, I mean, which try to stimulate the child in ways that are compatible with the peculiar features of autism. I mean, like a different use of visual clues and that sort of thing. They do have some positive results in terms of the child learning to speak or the child being able to integrate into some environments. So I think these are the only currently worthwhile treatments. And
But they have some results. My understanding is they're pretty mixed.
Yeah, they have limited results. They certainly don't cure autism. They improve the symptoms up to a point. And they're probably more effective than the earlier they are taken. Of course, the brain is very plastic in the first one.
That's what I want to ask. Are they more effective the earlier they take? And you said that, and I just don't know this literature. Because it seems to me that it might be that if you do any intervention, some are going to do well with it, but it might be placebo effect. I mean, we just don't know. Unless there's controlled studies, it seems to me that we really have no good evidence And I don't know the literature enough to know are there.
Well, we have child psychiatrists and also
Yes, I would want to, I would.
can comment on this. Yeah. Kevin, you want to say something? Dr. Choi, please. My understanding is that now they have better intervention early, so the outcome is better.
Okay.
So an early diagnosis certainly
Makes a difference. Okay, thank you.
I mean, there have been real double-blind studies on,
That's okay.
I mean, double-blind studies on the effectiveness of teach or ADA. I'm not aware of real double-blind studies on whether it's more effective, but it's but maybe I actually only look at the studies that were quoted in a French report from the Ministry of Education of Health, which was published a couple of years back, so that there may be newer work. But I mean, there's something there. It's not a miracle cure by far, but it's definitely better than nothing.
Thank you.
Actually, the expert have the word. 推刚刚问的是说那个自闭症如果早期治疗，是不是真的有帮助？
Because early intervention through behavioral approach to communication, facilitations, that did work for many kids for their progress through, say, the construct studies. Yes. So in our unit, that we accept the preschool children to have intensive interventions.
Maybe I would like to add something before we go on with the question. Maybe I've sounded too negative on research on the genetics of autism. I'm very negative on its current diagnostic validity, but I'm not saying that this research is worthless, because this research, I mean, it is solid in that the results from the GWAS studies are reproducible, they are found by other groups, they are statistically valid, and they may allow us to understand some of the pathways that are disturbed in this syndrome, and therefore eventually to find some kind of treatment. I think it's a really a worthwhile scientific topic. It's just strong to at this time to think that it can lead to useful diagnostics.
First of all, thank you for a wonderful talk that combined the science and the social context in which this is happening. I want to express a concern and then ask a question. It seems to me that most disorders, especially if they're spectrum disorders or mixed bags, it's always genetics and the environment. But the science of the genetics is very exciting, and the business interests of the genetics is very lucrative. And so I think the environmental component gets underfunded or under-researched. So I guess my question is that the case with autism? Are there environmental links that would be worth researching that are sort of relatively neglected because they're not going to make the company a lot of money?
No, I agree with you. I mean, that generally that environmental research, research on the role of environment in these diseases is unpopular and yet important. I don't think there is much going on in the case of autism. We've had in the past examples of bad examples of environmental research. So of course the psychoanalytic view, but also the vaccines story, because there was a paper which was finally retracted after many years of discussions on linking a certain type of vaccination to autism, which turned out to have no scientific foundation after all, which actually generated a lot of excitement, and even now a lot of literature. You find dozens of books on Amazon explaining the link between vaccination and autism, and many people believe in that, and there's absolutely no scientific evidence. So I'm afraid this throws suspicion on the research on the role of environment, which of course is certainly important, and especially again environment during pregnancy. I mean, I used to believe that the so-called autism epidemic was just based on changes in diagnostic. But now I wonder if there might not be something environmental related to conditions during pregnancy, and maybe to pollution or whatever events, or drug use or whatever during pregnancy. It's continuing, the incidence is continuing to rise. Looks pretty strange.
So could I come back to Kevin's question about regulating genetic testing of not definitely that you refer to two models. One is the business model, and the other is the educational model. But I think we argue in our paper that there are some professional roles between these two models. Because this test normally usually used by doctor's prescription. But now we know that business company could make this commercial, make it DTC, and you can just give your sample to the company, they will give you the result. But if you got a result, if you get a result that shows positive or negative, but positive only means that it increased certain risk, and this risk is still not significant, unlike the test result in Huntington chorea positive disease. It maybe means that previously you had 1% in your lifetime, but now you are kind of a 1.5 or something like that. It may mean something, but it's still kind of remote. So we argue that maybe the professional body should advise, and for example, the Society of Genetic Testing or from Society from Psychiatry should advise their patient, or even advise the government, such kind of test should not be prescribed by commercial or by a pharmacist. It must be through the doctor's professional guideline to do that. So I think apart from business model and educational model, professional model might be a useful advice. So I'm not sure whether that applies to France or in Taiwan or US. I think in the US probably there are more market-driven force to allow that to happen. But in Taiwan, maybe we should have some psychiatrists, whether when there are some company in Taiwan, maybe in what sense they want to sell this. It could happen in other kind of disease. They want to sell the BRCA genetic testing kits in the supermarket. So should surgeon or should psychiatrists come forward and advise? No, this should be banned.
Yeah, the psychiatrists are very happy that they're going to have this kind of power to be the necessary learning immediately to explain what the result is. But I think that, but in that kind of situation, maybe conflicts of interest will be another topic that we have to deal with. Maybe we would be buy off by the genetic companies. Yeah, that would be worry about that. Thank you.
Any other comments or questions?
Feedback for this question that I would like to take on the educational approach, because that if we do education appropriately to the parents they also have their associations. They can put more, say, proper information on their website. They will spread that. Maybe that's better.
So go back to the patient's group.
Just a general observation about how complicated, on your general point about genetic testing is. I mean, you know that the testing for APOE gene, is linked to Alzheimer's, but it's also linked to hyperlipidemia. And at least 5 or 6 years ago, and I don't know what the current standards are, the American Society for Genetics and a couple of other societies argued that that test should not be administered for hyperlipidemia for diagnostic because the association with Alzheimer's, because of the worry about people discovering that they might have that. But that's really, it seems to be extremely controversial for the simple reason that somebody who is at risk for hyperlipidemia wants that genetic test, and the thought might be expressed like this: well, I'd rather know if I'm at higher risk for heart disease because I can die long before I may develop Alzheimer's. So I mean, I think we have to be careful about how we regulate, because a lot of times regulators themselves impose values. Alzheimer's is a terrible disease that we ought not to disclose to people that they have a higher risk for. But that's a very paternalistic judgment.
But do you know about that relevant bank test?
No, I think about this topic, we have one question, which is education of MDs and the time they spend with the patients. And maybe a partial answer is having more genetic counselors. We don't need to be MDs, but we can spend the time to discuss these issues with the patients. It takes time for things to be understood. And also, I mean, the more general issue of probability, how people interpret probability. If I mean, a high risk is not a certainty, and a low risk does not mean you are immune, and that's very difficult to get across. And yet, I mean, the probability only means something at the level of a group. It doesn't mean anything solid for an individual. And actually, there was an investigation of DTC companies by the Office of the Congress, where they ordered tests from several companies and tested the same DNA with different personal histories from the different companies, and got conflicting results, and they exposed that really much of what these companies do is completely unreliable. But even that body from the Congress, the Office of something, they showed that they didn't understand probability, because they said, this company's test say that I am a low risk for, well, that this person is at low risk for heart disease, yet he's wearing a pacemaker. So they thought that low probability meant that you were immune for the disease. But I mean, I can be a non-smoker and be affected with lung cancer, or I can be a smoker and live happily to 100 without any lung problem. So that's also a matter of education, but it's pretty hard to get across.
Jeff, do you remember the guideline for dementia genetic testing?
Yeah.
When that come to this case, when you do this test, it tell you about the risk of heart disease, but at the same time review the dementia. Do you remember any restriction on that kind of testing?
You mean the
No, dementia. Because George asked about ApoE review both dementia and also the heart disease part. We have just reviewed the guideline for genetic testing for dementia. But I think in general the principle is that this test will not be forbidden. But when before you do that, you need to explain very clearly the implication those refer to heart disease as well as dementia. Okay? And then you want to know about heart disease, but when you do that, the test result is available, you inevitably must face the consequences of that dementia. But if you want to know both, okay, he has proficient, adequate genetic counseling before testing, I think that test will be allowed to do.
I think based on the counseling process, the counseling process is very important before you do the test. There are many criteria we have to meet. So probably the counseling process when the disease will happen or the actually happen, the incidence rate, there may be a considering point. So depends case by case, not the same on the case.
Do we have other comments or questions?
I have a comment based on my discussion with my colleague Jamie, is that it partly probably echoes what Jim was saying, that because for a test to be ethical and beneficial, treatment or intervention has to be available in order for that test to be ethical. I think the problem for autism perhaps is that the infrastructure for treatment in some country or society may not be that widespread or accessible. For instance, children may have to line up for months before they can get effective intervention. And in these societies, if you have a genetic test available, the testing would be unethical, because even if the test is sensitive and specific, still they don't get any treatment. So my comment or argument would be, before we invest in a lot of these genetic testing, perhaps what is more practical is to upgrade and make our the infrastructure for treatment and more available. And if treatment, that is the professional for treatment, including the psychiatrics or workers for child care, is more capable, then perhaps genetic testing may not be that useful, because we would have many professionals there to help us diagnose these syndromes earlier compared to genetic testing. Because my guess is that perhaps the diagnosis for autism may not be that complicated if parents are educated to watch for certain syndromes and then to get, if the availability of professionals are higher, then perhaps genetic testing may not be that crucial. That's my comment or my suggestion for policymakers compared to genetic testing.
I'd like to react to that, because I had a discussion with the CEO of Integragen this spring. I wanted to visit them again before sending my book to the printer. And so, of course, he's defending his test. And what he says is that there are very few really capable clinical geneticists or clinical psychiatrists who have seen enough autistic children to be able to make a diagnosis. And so he defends his genetics test by saying that a positive result doesn't mean that the child will be autistic, but it means that this child should be put on the fast track to see one of the best specialists. And so he argues that the risk of not doing the test is to delay diagnosis and therefore make intervention more difficult. So it makes sense, but
yeah.
So this test is based on resources allocation reasons.
Just one more comment on the social context. Years ago, there were beginning to be all these associations of parents with children who were affected by different diseases. And I thought it was a wonderful development, really in the spirit of democracy, because people could share their experiences, help one another, and so on. But the more I've read about it lately, it seems that the drug companies and the genetic companies realized the best way to lobby is through these parent associations. So they fund them, they quote, help them, so they become another lobbying group. And I think that's really a shame. And I don't know, of course, what to do about it.
So we go
But
back
if the
to-
drug companies know if they lobby, there'll be a reaction against them. But if they fund the money through the parents' associations and the parent association lobbies, you know, who's going to argue with the parents of these affected children?
Do you have any friends?
Maybe this is not stupid.
No?
Not so much in France, because again, of our
Yeah.
particular situation with respect to genetic testing, but it's certainly the case in the US.
So we need some conflict of interest rule in this kind of science promoting activities. So I think, yes, we're done now. So ladies and gentlemen, please join me to thank the wonderful speaker and for the special.